Okay, so we're going to start with factoring quadratics, and we're going to be using the AC method, and this is just one way you can do it. There's other ways, but this is a very basic way to factor a quadratic. And I call this the AC method because what you see is we have three terms here in this quadratic expression. I've got an A term, a B term, and a C term. Now this is in standard form. You'll notice that the squared term is in the front, and then the B term just has a variable x, and then the last number, the constant, that's just a whole number. Okay, now this is already in standard form, and we call this the AC method because when I am factoring using the AC method, I'm concerned with the two numbers here, which we would call, this A term here in this case is whatever is in front of x squared. Well, there's a 1, it's an implied 1 in front of x squared. Now we're going to be dealing with quadratics eventually where the A term is something other than 1. So there may be a different number in front of that variable. And the C term here is 20. So those are my two numbers that I'm always going to start with, the A term and the C term, and I'm going to multiply them. So I'm going to multiply 1 times 20, and that's always going to be my starting point. A times C multiplies to what? Well, it gives me 20. And I'm going to be looking for factors of 20. Okay, that's why we call this factoring. But I don't just need any factors of 20. They have to be a specific set of factors that will add to the B term, or this middle number right here. So I'm looking for factors of AC that add to my B term. Okay, so it has to be these specific factors of 20, not just any factors of 20. So if I'm thinking of, factors, those are numbers that will multiply to give me something. So the factors of 20, I could say, okay, well, I know it's, there's 2 times 10. That'll give me 20. All right, but 2 and 10 will not add to give me 9, so I'm going to go through all the factors of 20 that I know. I know 5 times 4, 20 times 1, okay? And once you figure out what the factors of 20 are, I want to check and see, do any of these factors not only multiply to 20, but do they add up to 9? So 2 and 10, that's going to give me 12. So that's not going to work. 20 and 1, kind of obvious, that's not going to work. But 5 and 4, if I multiply 5 times 4, I get 20. And these numbers also add, if I were to add them together, they're going to work out to give me the B term. They're going to give me 9. So these are the factors of 20 that add to 9. Factors of AC, when I multiplied AC, that add to B. So that's the way we're going to do this every time. The beginning step of factoring is always to multiply A times C and see what multiplies AC and adds to B. Okay, so these are my two factors, 5 and 4. Now what I'm going to do though is I'm going to write these out. I'm going to use parentheses here, 2 sets of parentheses. I'm going to write these out as factors, and the way that looks is these are two positive numbers. I've got x plus 5 and I've got x plus 4. That's how the factors are going to look. It's going to look like two binomials here. So x plus 5, x plus 4, and those numbers just came from these two factors right here. I had 5 and 4. That's what I'm using when I break this down into factors. And if I was just asking you to factor, this would be what your final answer looks like. Okay, it'd be x plus 5, x plus 4. You would just take those two factors and write them out as two binomials. All right, now let's look at another example here just to make sure we kind of understand what we're doing. Now, here I have a different quadratic, different numbers, but the process is always going to be the same. I'm going to start looking at the A. That's my first step. Look at the A and the C. A term and C term. In this case, it's 1. It's always there right here. If there's not a number there, it's implied that there's a 1 in front of that x. So I've got 1 times 15. In this case, when I multiply A times C, I get 15. And that's my starting point. I'm looking for factors of 15, numbers that multiply to 15. But remember, it's not just any factors. They have to add to give me this middle number. That doesn't look good. They have to add to give me 8. Okay, so that's the specific factors that I'm looking for. And 15 doesn't have a whole lot of things that multiply to give me that. So I could say, okay, 5 times 3 and 15 times 1. And that's all the factors of 15. But I need to make sure that I pick the right ones. I can't just pick any of those factors. It has to be the ones that not only does 5 times 3 multiply to 15, that works. It also has to add to give me this b term here, and that's how I know I picked the right two factors. 15 and 1 would add to 16. It wouldn't work. And I'm dealing with all positive numbers right now, so I know the signs are going to be the same. So 5 times 3 does multiply to 15. 5 plus 3, it does add to give me the b term. So it's always what multiplies to AC and adds to b. That's how I'm starting this whole process out. And now there's going to be different scenarios here eventually, but right now that's all I'm doing. And I will write this out. When I write my answer, I will just expand this, and I'm going to create two binomials. And since my variable was x here, I'm going to write this as x plus, take these numbers, x plus 5, since it's positive 5, and x plus 3. I'm just using those two factors that we got, and this is what my answer would look like if I factored this. Now, these factors, if I were to take x plus 5 and multiply it by x plus 3, I would end up getting exactly what I started with up here. So we're finding factors of x squared plus 8x plus 15. And a factor just means that those two binomials that we just got, these would multiply to give me my original expression up here. Okay, so that is what factoring is. Now I want to look at an example where the a term isn't 1. It doesn't change the process of what I'm doing, but it is going to make me go one step further. So let's say, for example, I had 2x squared plus 7x plus 6. Now my a term is actually a number bigger than 1, and my c term here is 6. I'm still going to start out exactly the same way. Okay, so I've got 2 times 6. That's going to give me 12. So with this, in this specific problem, the a term isn't just 1. So I have to look, and that's going to require me to do an extra step in the end. So 12, I got that from AC, just like we were doing earlier, a times c. And I'm going to be looking for factors of 12 that add to this middle number right here. So what multiplies to 12 but also adds to give me 7. Alright, so factors of 12, if you start listing things that you know will multiply to 12. So I know 12 times 1, 2 times 6, and 3 times 4. Those are the factors of 12. Well, which ones add to 7? And it's pretty easy to look at sometimes which ones work. 12 and 1 doesn't work. 2 and 6 is going to give me 8. But 3 times 4, that actually works. But now I'm going to have to do something a little bit different here. I'm just going to have to go one step further, and this is the step people always forget to do, because the first steps are always the same. Multiply a times c. What adds to b multiplies to ac. That's always going to be the same. But once I get to this last step and I start writing this out as two binomials, I've got x plus 3 here, and I've got x plus 4. This part is exactly like the last examples. Everything's the same. But if your a term is a number that's bigger than 1, I have to do something extra. I have to take this a term, and we used to call this bottoms up. And the reason I call it that is because I'm taking this a term and I'm going to divide both factors by the a term. So my a term here was 2. I'm going to divide both of these numbers by 2. Alright, and that's how this is different. That's the extra step. And something's going to happen every single time. It's either going to go evenly. Like, let's say, you know, what's 4 divided by 2? Well, that goes evenly. And I'm just going to reduce that. 4 divided by 2 is 2. That's my factor on the right hand side. Now you'll notice on the left over here, 3 and 2, they don't divide perfectly, and that's okay. If it doesn't go perfectly, sorry, 2 doesn't go into 3, don't worry about it. I can't reduce that fraction, 3 over 2, it doesn't reduce. And this is why we call this bottoms up. If it doesn't go in, 2 does not go into 3, I just bring whatever's in the bottom up here to the front. So my new factor, I brought this 2 to the front, is going to be 2x plus 3. So hopefully you see what I did there. I just brought the 2, it did not go into 3. And that fraction can't be reduced. So if it doesn't go evenly, bring it to the front. I don't have to do anything crazy or weird. This is my factored answer, my final answer here. So always check your a term. You know, when you're factoring, it's easy to get in the habit of just a times c, what multiplies that and adds to b, and you get your answer and you think you're done. Always make sure you check this a term up here. If it's a number bigger than 1, you have to divide both factors by that a term. If it goes evenly, like 4 divided by 2, you just bring down the answer. It becomes x plus 2. If it does not go evenly, bring that answer to the front. Okay, so bring it up. That's why we call this bottoms up. Whatever's in the bottom, if it does not go evenly, bring it up to the front. Okay. And I want to look at one more example, and this one has negatives. All right, you're going to be dealing with different signs. The signs are important. Don't just multiply the numbers and ignore the signs. Here the a term is positive 1, but I'm going to multiply that by the c term, and that's a negative 14. So that's important to pay attention to the sign, because when I multiply a times c, 1 times negative 14, I get negative 14, not positive. And that's important to make sure you distinguish between, is it a positive or a negative, because that's going to impact my final answer here. All right, now my b term is negative 5. So I'm trying to multiply to get a negative number. The only way to do that is if my signs are different. So the signs are going to be different. I know that right off the bat. Okay. And I'm going to add these numbers to get a negative 5. So I know the bigger number is going to probably be negative, so that I get a negative outcome here. All right, so what multiplies to give me negative 14? Well, the signs are going to be different, but I know 7 times 2 gives me 14, and I know 14 times 1. The signs are going to be different. Now, there's nothing I could do with 14 and 1 to ever get negative 5, so that one's right away out of the question. But 7 and 2, I could subtract 2 from 7 and get 5, but I need a negative 5. So I know it's going to be 7 and 2. I just got to figure out how the signs are going to play out here. Okay, so 7 and 2. Well, I want to end with a negative number, so I know that I want the bigger number in this set to be negative. Okay, so different signs, negative 7 times 2, that checks out. It does give me negative 14. But I want to make sure that when I combine these two numbers, negative 7, positive 2, that it also gives me negative 5. Now I don't have to do any bottoms up or anything. This is just a basic, the a term is 1, so I don't have to do anything else. But when I write this answer, got to make sure that the signs match. Okay, I've got a negative 7 and a positive 2, so that's going to be x minus 7, x plus 2. And when we factor, the signs do matter. When I multiply these out, I do need to get something exactly like this, and I have to have the signs working the way they need to work. So you got to remember how positives and negatives work. If you multiply two negatives, you're going to get a positive. If the signs are the same when I'm multiplying, I'm always going to get a positive. If the signs are different when I multiply, I'll always get a negative. Okay, so just remember that when you start seeing signs, you're going to have to kind of play with the signs to see which ones will give us the correct answer.